Well, good morning, good afternoon, good evening, and especially a good extra early morning today, since serverless office hours is slightly earlier than normal. We appreciate you joining us a little bit earlier. If you are watching this recording a little bit later, sorry it's not quite going to be live on your normal time, but at least you get all the goodness of serverless office hours. So, yeah, welcome everyone, wherever you may be across the lovely world. Thanks for joining us live if we are early or on the recording later. And we are streaming on the AWS Twitch channel, YouTube Serverless LAN channel, and also via LinkedIn Live. We've actually got people from across 3 continents today, which is pretty impressive. Gregor is in Singapore, I'm in London, and Sindhu is on the west coast of the USA. So we're literally spanning the globe. First of all, Sindhu, welcome to Serverless Office Hours. This is your first time, so thanks for waking up extra special early to talk to us today.
Thank you. Thank you, Julian.
So,
Glad to
Sindhu,
be
you
here.
were a solutions architect and you're involved in AWS EdTech. What is AWS EdTech?
So EdTech is basically education technology customers that provide education-related tech softwares for customers, for students in schools. They also provide skills for your long-term learners who are, learning, trying to learn new technology or career choices.
Oh, interesting. I know there's a whole program. Universities are often looking, and educational institutions are looking at how to revamp all their educational services because obviously with cloud, let alone serverless. Oh, here I go. Services and serverless can be interchangeable, as we're going to hear later. But yeah, there's obviously a big drive within the education sector to modernize and even teach serverless because it's a really great way for students to learn technology. So I'm glad you're part of it to help the world get involved with serverless.
Yeah, and I get to be part of the technology that my kid uses in everyday school. So it's interesting and exciting.
Cool. Well, you can say hi to your kid, and you can be on the streams and look really cool with all the cool technology you're going to show. And Gregor, welcome back to Serverless Office Hours. It's late for you, so you're after dinner time. So yeah, thanks for joining. And interesting news from being previously an enterprise strategist, which was on the sort of architecture kind of side. Is it fair to say you've now moved? Taken the elevator down into the engine room. You're now part of the serverless organization as an evangelist. How did this change come about, and what prompted it?
Yeah, that's very much appropriate. And basically, the short story is that as a strategist, I got to meet with a ton of customers. I checked my stats, and apparently, I did 409 events and customer meetings and sessions. And of course, that gave me a ton of great ideas and input. And in the end, I actually wanted to go and implement some of those. And so I joined our serverless team, and I'm now working on our serverless product offerings. And it's actually a lot of learning for me, but also a lot of fun.
Excellent. Well, we work within a sort of bigger organization together, so it's awesome to be able to leverage your expertise starting from today. So yeah, just looking back over the past week of serverless in the world of serverless on AWS, the last stream, which was a romantic Valentine's Day stream with Anton Alexandrov and Todd Golding, where they were talking about multi-tenant serverless SaaS. So this was really interesting, talking about if you're running a SaaS business and you want to be multi-tenant, serverless is really helpful to do that. And they had a whole bunch of tips and tricks to do that. And that is available with the recording with all other serverless office hours episodes on the Serverless Land YouTube channel. Just in terms of what's new that's been coming out, we're going to be talking about some cool integrations today as well. And yeah, Step Functions just keeps adding more integrations, another 35 services, including EMR serverless, which is part of their SDK integrations. I think it's something like 10,000 SDK integrations that you can just run directly from Step Functions, which is super useful. And yeah, just quickly, Cognito now has its the identity pool data events available in CloudTrail. So if you're doing any monitoring or governance things with CloudTrail, that'll help. And Kinesis comes out also with CloudFormation support for global tables for DynamoDB. So if you are using DynamoDB and that's with streams as well, then that'll be super useful for you. In terms of recent blog posts that have been coming out, yeah, step functions up again, sort of reactive progress tracking using step functions. This is really cool. If you think you've got a state machine and sometimes you running a state machine and you want to see what the updates are, well, Alexi and Max have done a really good blog post of using a WebSockets layer that you can have a front end, and using those SDK integrations from step functions, you can just send updates to the front end via a WebSockets connection via API gateway. So that was a really cool and interesting use case, which I can immediately see lots of applicability. So that's useful. And then Oh, sorry, I did jump before we getting over there. I was just going to mention the token-based auth for iOS applications with Amazon SNS. That has been also a popular post. But this week, on our slightly earlier time, excitingly, we are talking all about refactoring to serverless. So, Gregor or Sindhu, who wants to set us off? Where does this come about, refactoring to serverless, and how come it is important?
Yep. So the story starts basically refactoring is a relatively well-known term in the industry, right? And it means restructuring your code, usually for the better, without changing the functionality. So it's about improving the structure of your solution. And we realized that actually in the cloud, there's many opportunities to do that at a larger scale, particularly in the serverless environment. And as we'll see, that in the serverless environment, automation is a big part of your application. So many of these refactorings actually shift application code to automation code. And we thought that is really, really cool. So we started building a catalog of those refactorings. And Sindhu was actually the first volunteer from our technical field community to start this. And now we have like about half a dozen contributors to the work that we want to share today.
So is this, obviously, when you're migrating applications to the cloud, you could do lift and shift, and that's just sort of rehomering it. And I think there was sort of seven different words, all starting with R, of different ways of sort of migrating to the cloud. But obviously, a refactor is additional work for people, and some people are put off by that as well. Is part of this, in order to use the cloud as well as you possibly can to save costs, be more agile, and be more flexible, serverless is the best approach. And so if you are looking at doing any refactoring, is there a starting off point you would think you would start off with, or do you just learn about serverless and ultimately serverless is where you want to be? How do you sort of frame it in terms of that journey?
Yeah, so there's a chapter in my book about all the R's. So there's a 5R, a 6R, and a 7R version of the ones you're referring to, depending where you look. But these refactorings, they are slightly smaller, but also more dynamic. So they're not tied to the initial migration, right? Like the 5, 6, 7Rs, they're like, okay, I'm going to move my big application from on-premises to the cloud. So, do I just rehost, replatform, refactor that? What we're talking about is like you're actually all in, right? You're building cool cloud-native serverless applications. So would say in the vocabulary of the original R's, you're sort of at, like you said, you're like at the top end of the scale. But of course, there's still different ways of doing things, and you can always improve your solutions. And that's where really our refactorings come in. So it's something that you'll do much more continuously, and it doesn't mean something is bad or something is broken. Just like refactoring Java code, it should be part really of your development routine.
Okay, and I suppose it's just not, well, as you're going to talk about, it's not just the code refactoring, but part of it is as the AWS ecosystem evolves and there are more serverless services, even talking about the step functions SDK integrations, the 35 new things you could do with serverless that you couldn't do a week ago. And so I suppose part of the job of architects and designers and builders is not necessarily to keep on the bleeding edge, but just be aware of what's going on in the whole world of AWS services, because when you can take advantage of them, well, maybe you're going to reduce cost, you're going to reduce latency, you're going to have improved availability while you're building your cloud applications.
Yeah, and I think that's a nice way of putting it, right? On one hand, building serverless solutions is a bit like being the kid in the candy store. I know that's how I got sucked in. Happily, right? And here I am, because it's a fantastic way of building apps, but it also means a lot of things, a lot of new things. So sometimes getting the trade-offs and the nuances crystallized is not easy. It's easy to get lost chasing tasty candy, and there's tons of it. So what we're trying to do here is give people also a good way of seeing some of the nuances. How am I trading off decoupling versus latency versus cost versus maintainability versus resilience? Like all these typical architecture kind of questions, they are then behind those refactorings. They drive this refactorings to improve some aspects, but you might also have to make trade-offs in other aspects. And getting this sort of architecture mindset, my architect elevator pitch. So getting this architecture mindset back into this design process, that is a big part of what the refactorings are about.
Yeah, and I love the way you have always talked about the pros and cons of things, because it is always trade-offs. And lots of people are going to say, well, serverless is going to be the be all end all of everything, and some people are going to say, well, I'm not there yet. And there's nuance to both of it, because you can't just migrate everything overnight. And we're talking about more advanced customers who have already bought into the cloud and have already bought into serverless, and now they can do even more. But yeah, it's really important for architects, I think, to understand where they are in the journey and what they can and can't do. And some of it's not tech, some of it's also organizational behavior.
Mm-hmm.
But hey, Gopal, thanks for joining us from LinkedIn. Yeah, it's an interesting question. Would you consider refactoring the key to becoming cloud native versus running in the cloud?
So these are loaded. It's a really good question. And these are always a little bit loaded terms. I have my view on what cloud native means. I consider cloud native something that uses the native cloud services, right? That's the way you want to build for the cloud, and serverless is perfect for that. I know not everybody has that the definition, but I find that the most meaningful one, right? It's natively on the services that you have, and you'll see many of them right here. Now, I don't know whether doing refactoring is sort of the one thing that gets you there, but I think it's a really good practice of working in that style, because one of the set of refactorings, and Sindhu will explain more of this, one set of the refactorings comes from the fact that the platform capabilities, the AWS serverless capabilities, they improve all the time. So you might have built something via written code yourself, and now you can actually do that in the platform, right? And we'll have examples of this. And I think doing that is a really good practice for native development, because if you can do something with the services that are provided, and that's the definition of being cloud native, then as new service capabilities come along, updating your code to use those, or refactoring your code to use that, is actually a really good way to maintain your solution in tune with the capabilities that the cloud gives you. So from that perspective, I would say, yes, it is a useful part of developing cloud-native solutions.
And I suppose some of the refactoring you're talking about is actually reducing a lot of that code. Either it's going to come out of your application code and into your configuration code, or it's just going to disappear completely, where it becomes a platform feature that something has come out. And that sort of led on to another question I thought of, was, how complete, or maybe how true, are the refactorings? Are we just using a sort of strangler pattern to take little bits and pieces off? I mean, do they preserve the sort of functionality, maybe the cost and the latency? How much of the refactorings is really going to take away part of your application? Is it bits and pieces, or a whole bunch more?
Yeah, Sindhu actually has a great example for that one.
Yeah, I think we have an example that we'll show later on, where we'll try to see if the refactoring before and after actually preserve the behavior. You don't want to lose the business functionality, but it might introduce some side effects, and it's very important to be aware about those side effects, and then see the total picture in, like, what are you gaining, like you said, what are the trade-offs that you need to make while you're doing this refactoring.
Mm-hmm. And it's important to keep in mind, right? You're building distributed, fine-grained distributed solutions here, right? The traditional refactoring is in code, so it might have small side effects, right? Depending on your runtime in your compiler, like introducing a variable might introduce a small delay. Like for most business developers, that doesn't matter. If you're writing embedded code, that might actually. So there's small nuances introduced, but in the normal refactorings, we cannot tend to ignore those mostly, right? Like embedded probably being a special case. In this case, right, you're building distributed solutions, so they have latencies. The services cost money, right? They're not 100% free. So you have other runtime considerations, and sometimes they're actually driving the refactorings, like you want to make something asynchronous, you want to decouple something, and sometimes they end up being a side effect, just like Sindhu says. But in the end, this makes, in our view, the refactoring is actually quite rich, because they're no longer just sort of a code, like, do I make my code look prettier, if you want to trivialize it, right? But it's much more like, what does my architecture look like, and can I improve my runtime architecture? So that is a whole other level for these kind of refactorings, and I think that's super interesting.
And is there a right time to refactor, in addition to it sort of being a continuous thing? So I suppose two parts of the question: is there a right time to start, and then a right time to get going, or how does one think about this in terms of a project or product life cycle?
Yeah, isn't that like this smart saying, like it's pretty much for any improvement, whether it's improving your health or whatever it is, the best day to start is always today, right? So I think for anything that's a good practice, the same advice goes here, right? Just like it used to be, let's say if you rewind like maybe 20 years, it would be like a developer would say like, oh, I should probably refactor this method, right? It was like this epiphany where like, oh, I can put a method, yeah, I can extract a method, I can rename this variable. And he would go and like, oh, today you write in your log, like today I refactored something. And that has totally changed, right? Now we have this built-in tools, IDEs, like it's become a completely continuous practice. Like nobody will tell you anymore. It's like, oh, now I'm going to refactor something. It's become an ongoing good practice. And I think this could happen also to these cloud refactorings, right? Like in the end, we should just embrace them and it should be just part of the normal process. And you more or less do it all the time. It's like writing tests, right? A lot of people even have sort of this red-green refactor life cycle, right? In OO, test-driven development, right? Is you make a test, you make it red, then you make the test green, and then you refactor to make the solution good with some air quotes. And that is like the normal development cycle. So I think the same can actually apply here. So it wouldn't show up on the project plan, like this week is refactoring, right? It's not like a bug fixing, but it should be something whenever you see an opportunity for this, you go and improve it through a refactoring.
Yeah. So like
you have continuous integration. Glad you're joining us, Minish. You're going to start tomorrow, so that's also a good start. Maybe today.
Yeah, as long as tomorrow you don't say the same thing, that's all right.
Exactly. Today would be proactive. Tomorrow might be reactive.
Yeah, exactly. Sorry, Sindhu. Apologies for cutting you off.
No, you're good. I was saying like you have continuous integrations, deployments. You probably need to have continuous refactoring. So new term thrown out there.
Mm-hmm. At least it's not with a D. Otherwise, too many DDDs at the end would be confusing. But there was a question. Now I was going to ask something else. And Ian, sorry for mangling your name. Thanks for joining us via Twitch. But what are some characteristics of an application use case where you would not suggest refactoring to serverless? And I was going to ask this in a slightly different way of, are there any prerequisites? Somebody doing this deciding they have some sort of architecture that maybe isn't particularly native in the cloud/cloud native, and they want to jump all into serverless. Can that be in some stage too big of a jump? Are there sort of some prerequisites that you may suggest before going maybe all in?
Good question. And we don't want to say that sort of serverless is the right answer to any kind of problems, right? That's why we have a wide variety of services, right? There might be cases where running an EC2 is the right way. There's many great use cases for containers, either in a traditional way or in a serverless way. And of course, there's many great scenarios where it's Lambda Event Bridge, step functions, DynamoDB, and all those things that we consider like the core of the serverless environment. What we assume with these refactorings, and maybe the title is a little bit, I hope it's not clickbait, but what we assume is that you're already using some of the serverless services. And you will see this in the examples, right? Like the vocabulary that we use in these refactorings. That is Lambda, that's Event Bridge, step functions, DynamoDB, DynamoDB streams, SQS, SNS, right? That's the kind of environment that you're working in. The reason we call these refactoring to serverless is because I'm convinced that serverless is not defined just by the services that you use, but also by your architecture. So let's say you have a giant brittle monolith that shares state with everything else, but you did that with DynamoDB and Lambda. I don't think you deserve very much, or your application deserves the serverless label, right? Because the style of application and it's like high latency and synchronous to make it worse, right? Like it doesn't really reflect the architectural style. So what we're trying to do here is show the spectrum that yes, you're working with these kind of services, and that is great, but you can sort of ratchet up your serverlessness. That's probably not a word, but I just invented it, right? You can sort of ratchet it up and take more advantage of these serverless services and overall make your solution more truly serverless. So our discussion is not like arguing between VMs, containers, and serverless, but looking within the serverless spectrum, how can you make the best application architecture?
And before we just, sorry, Cindy, yeah.
So, and also I would say, like, before you start into refactoring your applications, make sure you have good test cases that reflect the current system so that when you eventually make those changes, because I see that that's the biggest hurdle or resistance to making those changes or refactoring. If it works in production, don't touch it. So have those test cases written before you jump in. And then that way, when you make those changes, you have automated testers that can then see was there any side effects introduced and then react accordingly.
Yeah,
Yeah.
that's a really nice comment, right? So basically, if you're thinking that refactoring is a lot of effort, like if it shows up on the project plan, like this week we refactor, that is probably an indication that your software delivery lifecycle has high friction. And that could be because you have manual steps, like of testing, like Sindhu says, right? All these kind of things. And that really points to like, you don't have a refactoring problem, you have a much bigger problem. So what we are assuming here is that your software delivery is set up for a high rate of change, right? You can deploy, you can test, you can validate, you have automation. And in such a scenario, refactoring something like improving the structure of your solution becomes a very small thing that you can just automatically do it. So it's also a bit of a test for how mature is really your software delivery machinery. If refactoring ends up being painful somehow, then that's probably a signal that your machinery isn't quite as well oiled as it should be.
Yeah. I'm actually doing a talk next week at Serverless Days in Belfast. So if you're going to be there, I'd love to see you. And part of it is I'm actually looking at the DORA metrics, which is the DevOps research. Oh, I'm annoyed. I was looking at it this morning, and they're basically they're 4 metrics, and 2 of them for velocity, how quickly you can put things into production, and how you're basically from the code commit through to things in production, and then also if things go wrong, how quickly can you roll back,
right,
and some of those impact kind of things. And I think those DORA metrics are actually, in my opinion, are really far easier to achieve with a serverless approach, because serverless lends itself to small little pieces that you can get into production much faster. And so if you're wanting metrics, Sindhu was talking nicely about the testing in advance to know if things are going to work, but the metrics to make sure that things are working and your organizational delivery lifecycle is healthy and really good, then a serverless approach, because it is small, little small changes, but many of them, can really help in that approach.
Yeah, I'm a big fan of Accelerate and the Dormetics. Just humble old buddy of mine is part of that. Yes, and it's about cycle time. It's about redeploys, right? Those kind of things.
Yeah.
And I think they're really simple. They look simple, but they're really insightful metrics to sort of measure the maturity of your software delivery engine, right? If you're good on those metrics, like for example, it doesn't help you if your cycle time is totally short, but you have a ton of redeploys, because that means like you have speed but no discipline, not a good recipe, right? So the metrics basically balance each other, so that you have high short cycle time, right? You can deploy quickly, but you have a very low percentage of redeploys. That means the stuff that you deploy actually functions. And I think that makes these really rich metrics, right? They look simple, but there's a ton behind them. And I think that's why they're so popular.
Yeah. And really nicely measurable, and you can in any organization can set up really simple metrics to track these and see how they are improving over time.
Cool.
So remember, we are live. If you've got any questions you want, send them via the platform you are watching. But so should we switch over and see what you? I can switch over to your screen.
No, it's great. We got so many questions up front, right? But I think we said like 3 times now we show later. So I think now it's time to show. Now it is later. So let's share a little bit where we're coming from, right? And I want to zoom out tiny bit, not too far, to sort of explain where these particular refactoring started and what makes them special. And the key word there is automation, right? Automation is a key part of the cloud. The fact that there's a CLI, the fact that there's an API, the fact that you can just get resources in an automated way, that's a key aspect of being successful in the cloud, or vice versa, for the success of the cloud in the first place. But there's an important nuance here. And that is, in the past, when we talk about automation, we mostly think about sort of assembly line, right? I wrote a shell script so I don't have to do the same thing like 50 times over, right? We think of automation being something that makes a manual task repeatable, right? And that's good, but also that model is some years old. So we should expect that in the cloud, automation is more than just sort of taking the toil away. Automation covers more things. Particularly, it makes you faster, right? Speed, we talked about the metrics, right? If you want to have short cycle times, right, you're going to have speed, and you're not going to get that without automation, right, with manual steps. Repeatability, we talked about cycle time versus redeploys, right? If you do this by hand, it won't be repeatable, and then you just be deploying garbage. So automation makes things more repeatable, and this does something pretty magical. If it's repeatable, the teams gain confidence, right? One of the biggest problems in software delivery is if your team doesn't have the confidence that the deploy will work, they won't fix stuff that's broken because like, oh, I might break something else. And then you get technical debt and your code rots and also the other bad things happen. So having automation increases the confidence. It also allows you to do completely different things like disposing of resources, right? Many people know this as the pet and the cattle analogy, like we used to sort of maintain the server like a pet, and now we just like dispose of it. I don't use the cattle analogy, I'm a vegetarian, right? But we dispose of the server, no animals harmed, and we just recreate a new one because it's highly automated. And in the end, if you do things in an automated fashion, you get metrics. How long did it take? What was the error rate, right? Who did it, when, why? You gain all those kind of metrics. So it's a nice reminder that when we automate in the cloud, it's not like the old shell script. It actually has many more drivers behind it. And we often go as far, so I'm like citing myself here, the opinionated architect, to say that if you took automation out of the cloud, it unfortunately gonna look much more like an old data center. And that is really the premise for the refactorings. So to look behind modern automation, we realize that it does a lot more than just provision resources. So one thing it does, right, you have like Terraform or CDK or something or CloudFormation, it does provision resources. And I used sort of a trivialized example here of some load balancer and some EC2 instances, right? But by themselves, these resources don't do anything except maybe cost money. So what do you need to do? You need to deploy things on top of that, right? And even in the serverless environment, your Lambda function wants to have some code, so you deploy that, and you also do that with automation. But even this doesn't really do anything because the pieces are not connected. So you need to actually compose. I call this the topology. You need to define what talks to what. That's your architecture. And then last but not least, you often have small configurations like you pass environment variables, different kind of settings into your code. So as an architect, if I look at modern automation, I can actually see the 4 distinct layers. And I think that's healthy for us to understand that there's 4 different things. It's not just about provisioning resources. The automation does much more. And if you think about a serverless environment, that's actually a good thing because in the serverless environment, there isn't a lot of infrastructure to provision. We do that for you. So if it was only infrastructure, it means, oh, in serverless, I don't need automation, which is, of course, the exact opposite of what is true, right? In serverless, I want much more automation, and that's because I'm very much interested in the top part of the stack because the bottom part, we take care of you. And that explains why automation is a really hot topic and why there is a lot of activity in different languages to achieve that.
Yeah, and we see a lot of variety, also like evolution in the cloud automation languages. So on the right, you see the document-oriented approach. This is where you're describing your infrastructure and the configuration parameters in JSON or YAML, and you have toolings like CloudFormation and Terraform, which is from HashiCorp. So if you want to do, you need an S3 bucket, and that's the definition. It's a little bit verbose, but there's no object-oriented here. You're limited to what you can do. There's no loops and list. And on your left, I switched. I said left and right. On your right, you see infrastructure automation, which is using functional language like Pulumi with F#. And you do see some constructs like lists here. And what is gaining more traction is actually using object-oriented language for your cloud automation. And you can describe your infrastructure using TypeScript or Java, some of those languages that you are very familiar with as you're writing your application code. And this is tools like AWS CDK and others. And this is where it becomes interesting, because now you're using the same tooling that you use, same language that you used to for writing your application code and then writing your automation code. And as we'll see ahead, this is an interesting thought where it kind of blurs that line between application code and automation.
Yeah, specifically, so some of the examples on the right here, the functional languages, they're still a little bit sparse, but they do make a lot of sense because a lot of automation does like list calculation, like match, reduce, and flatten of lists because you calculate configurations. And this is one of the reasons, like, so BCL was one of those languages, proprietary. If you Google around it, you can find a PhD thesis, a little bit redacted, but it explains where that is coming from. And the same folks who created that, they're now making Q. And Q is very interesting. It's not, I wouldn't say it's necessarily a functional language, but it's sort of a purpose-made validation and data structure language. So what it's trying to do is it's going to blur the lines between a value and a type and a constraint. Super interesting, right? So basically, integer means all possible numbers, but you can say less than 10. So that represents all integers that are less than 10. Or you can have the number 5, which is one specific integer. And it makes sort of a lattice dependency structure out of that lets you calculate values. Sounds a little bit academic, and maybe is, but interesting sort of idea on how do you actually express your configurations. For now, I think CDK, I'm a big fan of that. That is an object-oriented land. We're very familiar with that, right? You code the same way you code the application, Node, TypeScript, Python, whatever you have. But there's things also that people are really trying to push the envelope to look at new languages just for cloud automation.
And for our example today, we'll be using AWS CDK, but the same concepts holds true whether you're using CloudFormation or a Terraform. And just for those who haven't worked with CDK, let me give you a little bit example. So CDK is an open source framework to define and provision your infrastructure. For example, on your screen, the first line, it says like, hey, give me a VPC. And give me ECS, which is for containers, elastic cluster. And then you have variables, you have classes and methods and callbacks, and you can use some higher level constructs, which is what I love AWS CDK for. For example, on the line 3rd, you see it says network load balanced Fargate service. That's a bit mouthful, but what it means is that CDK will create a new Fargate service which is running on the ECS cluster that we define on line number 2. And it will provision that and put a network load balancer on top of you. So that one line does all that work for you, which would have been several lines if you would have otherwise written in CloudFormation. And then you get other features that you use with your IDE, which is your autocomplete and documentation, renaming, and others. And you write this using your familiar coding languages like TypeScript or Python, Java, .NET, and Go.
So with that, being able to write automation in actual object-oriented code, I often joke that actually should lead us to rename the moniker that we commonly use, right? We say infrastructure as code, but we already realized in serverless land, this is not really about infrastructure because that's all taken care of. Like EventBridge and SKS is not infrastructure, that's part of the application, and Lambda for sure. So I think it's really much more than infrastructure. And with CDK, it becomes actual code. You're not having sort of a documented configuration file. You have the same language that you're using to write application logic. So I sometimes coin this the term IaaC. It's actually a chapter in my cloud strategy book where I call this infrastructure as actual code. And I think that is really cool. And that brings us back to sort of our 4 layers here where we said, where's the action here, right? Where's the interesting part with infrastructure as actual code? And it's the composition, right? Because you think about it, that is your architecture. And I just sort of with one eye followed the comments here where somebody was asking about a bigger refactoring, and the answer was, maybe you do a giant mono lambda and then you refactor this into individual lambda functions, right? that is the topology, right? You either have a big thing or you have many small things that communicate. Maybe they call each other directly. Maybe you have a Lambda destination. Maybe there's an SQS in the middle. Maybe there's an SNS. Maybe a step function drives the whole thing, right? That is the topology. That's your application architecture. And that gives it the resilience, that determines the latency, that determines the error modes, right? Your data consistency. Like this really determines how your application functions. And that is expressed in your automation, right? That's not in the application code. That is in the automation code. Granularity, perfect example in the chat, right? Big grain or coarse-grained or fine-grained. Yes, we all want to be fine-grained at some point, but often we start coarse-grained, right? Matter of topology. What talks to what? What are the dependencies? I'll usually find out when IAM is calling you back. That's the old joke, right? But you should sort of know what talks to what. Does it do that synchronously? Does it do it asynchronously? Is this a polling model? Is this a synchronous invocation? Is this event-driven, right? All these things are part of composition, and that is defined in your automation. And this also means we have a lot of customers where sort of automation is still considered the infrastructure team. They say, hey, application developers, you write the code and we do the infrastructure configuration for you. You realize that that doesn't really work in this case, right? Because this is not infrastructure by any means. This is the application architecture. And that means that the application teams are doing a large part of this kind of automation, because it's not the Ford Model T automation from 100 years ago, give me a server, right? And file a ticket for that, but is really building and defining your application. And that also gives the basis to these refactorings, right? Because now application code and automation code really live side by the same team, done in the same language. So you're kind of starting to wonder, how do the two relate to each other? And can I refactor one to the other? And here's another self-quote, right? And that is really that the lines are blurred. In a highly automated serverless environment, you can achieve the same thing in application code and in automation code. So this big dividing line that some large customers have, the automation is here in infrastructure and like application is over here in application development, that really doesn't make much sense in this setup. And I consider this a good thing, because this really defines the power of building serverless applications. I often try to highlight that serverless isn't just like a different deployment runtime for your code, like VM container, Lambda kind of thing, because A, a lot of serverless runs on containers anyway, and B, it'd be missing the point, right? It's the topology, it's the way you think about automation, it's to think about loose coupling, asynchrony, event-driven. That's all. We commented on this earlier. That's all what actually makes you serverless. And that's where it's really good that these lines blur, because the topology is an integral part of the application. If you're fine-grained, how it's wired together becomes fundamentally important. If you only have one piece, you can say, that's later doing deployment. If you have 20 small pieces, like the 20 small pieces mean nothing unless you have your topology defined, and that you do in the automation. So that explains why suddenly these big dividing lines don't really make sense anymore. And that's where we come to the term of refactoring, right? So
Gregor, I just want to jump in just before we go to
ahead.
the refactoring bit. I think some of those words are interesting, because even talking about the topology, because I know some people thinking infrastructure as code, and you 100% correct on that sort of traditional dividing line between the application code and the infrastructure code. And I and many other people have said that line blurring, that in serverless, your infrastructure is your application. And some people have said, well, in a way, it's a graph of resources. Let's not distinguish between application and infrastructure. So you've used the word automation as well, and even the topology. So maybe we need to be thinking of this as topology as code rather than infrastructure as code, or a graph as code, or something like that. Because I know that term infrastructure is, I think, a mental blocker for people.
Yeah, and I don't think we want to sort of undo the term that everybody uses, right? So in the end, I think that is fine. I always say the problem we have in the industry is the terms that become popular are generally the ones that are not good, like they don't describe really, or by the time they become popular, they don't really represent what they're supposed to represent anymore. So I think that is fine. But in reality, the way we should look at that is, yes, I much prefer the term architecture as code or topology as code. And the big difference here is if you think about your resources, and I like your sort of flow and graph analogy. If you think of resources just as nodes, right? Here's an EC2, there's a VPC, there's like, RDS, right? Whatever it might be out of the 200 plus services, you don't get the flow, you don't get the architecture, you get a collection of pieces. You basically get a bill of materials. And that's good for costing and other things, right? But you don't see how things flow. And if you think about it, some of these nodes, let's take SQS or EventBridge, my favorite example. All right, let's take EventBridge as a node. It makes zero sense as a standalone node. EventBridge's purpose is to route events from one place to another. So if you think about your application architecture, EventBridge is much more like an edge in the graph, right? It like SQS, same thing. SNS, same thing. They're connecting elements, destinations, same thing. So the idea of bringing these connecting lines into your architecture mental model, I think that is really the big step here. And with that, yes, you're really doing architecture as code, but I'm not sure whether I'm going to go into the history of cloud science as the one who managed to change the acronym.
There's another example. For example, if you are using, say, EventBridge to filter out messages, and now at that time, you're bringing in some of those business logic in the EventBridge itself. So that's, again, where you're mixing business logic with infrastructure code. And we'll show that an example later, too, if we get time to that. So it's a little bit more than topology also, which gets automated.
Mm-hmm. And I see a question here regarding the being deterministic. So yes. My history in Silicon Valley is I worked with very large functional languages at the time for automation, right? This was like large fleets, like 10,000s, 100,000s of resources. And I found that to be actually quite deterministic in the end. And I commented on this earlier. That's why sort of functional languages that very much work on manipulating data structures, I find are well suited. Now, in reality, we don't use them as much, right? Sort of like ListPlan, if you want, right? We don't use them as much in application development. So I think that's why with CDK, it's a nice balance with using object-oriented languages that people use all the time and understand well. And I don't think they not deterministic. Like if you were going to talk about high levels of concurrency and semaphore and things like that, right? But here we're basically what the code does in the end is calculate a data structure, right? The output is a data structure. Here's your manifest of resources. So I feel that that is totally fine. And the nice thing is you can actually write tests for some of these things. It's like going to become easier to test your object-oriented code. You can sort of mock out some of the actual resource creation. And with that way, you can actually make sure that what your automation code is doing is what you actually intended. A very good question.
Yeah, maybe.
And just going on to Robert says CDK is a pile of CloudFormation at the end of the day. So
yeah, that's great because you don't need to deal with a pile of CloudFormation, right? Because yes, CloudFormation is verbose in a way. Right? It's also sort of the grandfather of all automation languages, right? I need to remember, was it like 2011 or something, like a year or two before Terraform? It's like 2014, I believe. I don't have all the numbers in my head. So yeah, CloudFormation is like good 10 years old, right? So basically, it is kind of the assembly language of cloud automation, if you wish, right? It's low level. It's like if you want the ultimate answer, what your compiler produces, you can step through the assembly code. Like there is the buck stops there, but also not everybody wants to program that way. So CDK is a nice way, just like you have a compiler, right? CDK is a nice way to have a higher level language and not have to look at that assembly code all the time.
Sindhu, sorry, you were saying something, and then we.
I was saying we talked a lot about refactoring. Maybe it's time we can show an example, like how.
Yeah, probably.
Before and after.
Yeah, let's do that.
We're talking too much.
Yeah, no, let's not stretch people's imagination here further. So refactoring, right from Martin Fowler, a popular book, right? Many people will have. There's a website with it, and what does it mean, right? We hinted at this. It's improving the structure or the design of your application. It says code here without changing the functionality, right? So you're making a change that is not adding features. You're making a change to improve the structure of your solution. Why would you do that? Well, because a better structure can improve testability. It can maintain your velocity, right? If you never refactor it, you get a big ball of mud, and ultimately you are not able to add features anymore. That happens in very large object-oriented systems. Or in our case, because refactoring relates also to the runtime, right? You might want to reduce cost, improve resilience, decouple, make things asynchronous, right? So it's all ways in which your application is improved that are not related to building features. And that's why we felt that we can borrow the term. Martin's also a good old buddy of mine. We used to work at ThoughtWorks, so I'm sure he doesn't mind. And with that, really, Sindhu is right. It is time for an example. I hope we didn't build it up too much, because example has like 3 lines of code, but as so often, there's a lot behind those 3 lines.
So yeah, let's dive right in. Let's see a very simple use case. So on your left, you're seeing your business functionality, which is implemented using a Lambda. And where it is highlighted in gray, it's basically sending a message to the queue. So why would you want to refactor this code? So if you'll see that this Lambda actually has both the business logic and the interdependencies, what we call as the plumbing logic, all together here. And you have to pass these interdependencies to the Lambda, in this case, passing the queue names. And say in future, you want to change where you don't want to send it to a queue and you want to send it to a topic. You'll actually have to go, first of all, open all your code, find where the queue is being used, and then make that change. So let's see how you can refactor this code. So on your top is the refactored Lambda code, and pay attention to the CDK code, which is at the bottom. And the magic that is happening here is the Lambda destination. So we're using a feature from Lambda called Lambda destination, which allows you to send the results of a function execution asynchronously to a resource. Now, in this case, I'm sending it to an SQS. So now you can see after doing this change, I've moved my interdependency, all the infrastructure into the CDK, and on the top, the Lambda is now very clean. It only has the business logic. You can now know where the interdependencies are, and you know where the business logic is. So this is making your code more maintainable.
And I overpromised when I said it's 3 lines of code. It's really 1 line of code, and that is great, right? Because all it does is it returns a value, so you know it's message driven, right? It passes a value on, but where that goes and how that's being dealt with, just like Sindhu says, that is topology, and that's here Julia's comment. It's like, yeah, if this is topology as code, that topology should be in the bottom code, not in the top code, and that's what the refactoring achieves. Now, I should add one comment is, this is not a construed example. This is actually from, I believe, one of our own repositories, like some sample code I found, right? Because it happens so easily. Oh, I need to send a message. Well, let me get Boto 3 or whatever language I have, right? I do Python usually. Right, let me get Boto 3, like, let me get SQS, let me put the message, and let me send the message, right? That's sort of the way it happens very easily, but there is a better way. And then that refactoring reminds you that there's a better way and to go and actually change it.
Yeah, and so if in your code, in your Lambda, you are sending messages asynchronously to SNS or SQS, Event Bridge, or even another Lambda, destinations is one of the ways you can refactor. And talking about refactoring, and also this is something that we mentioned in the verse, why would you want to refactor? What is your motivation for refactorings? So I want to quickly share some of the benefits that you will see when you do a refactoring. The first one is you want to leverage platform capabilities, like we said in the previous example, using a Lambda destination. So you are reducing your lines of code. And so anytime I say, like, you see a code, it's a tech debt. Now, when you can take that away and use a platform feature, you don't have to maintain your code. You don't have to test that Lambda functionality because you're shifting that share of responsibility to the AWS service. And in generally, it scales better and is better and more robust than application code. AWS is constantly evolving. We are adding a lot of services. Julian mentioned about those 35 more integration SDK integrations being added. And so like this, you might find that where you had written code for a function that is now out of the box available by a service. So that's a time to refactor. The reverse can happen too. Like your application needs have outgrown the capability of a service. And so you take out that and write your own code for doing that logic. Refactorings can also improve your runtime characteristics. For example, if you are running into latency issues, that's the time you go back to the code and see how you can refactor, how things that you can take out, maybe a service here and there to reduce your code. And the last one, which is I work, as I said, in the edtech industry, and cost optimization is the biggest topic that is in forefront with my customers. So some of these refactorings also help reduce your cost, and that could be your motivation to find that place where you can refactor. And I say, like, because of all of this, refactoring should be an integral part of your development cycle. And Gregor mentioned, it should not be like an afterthought.
Yeah, I actually just blogged about this on my Architect Elevator site where I had an example where code is updating DynamoDB and then it's sending an event that it did that. I'm like, hey, the platform can do that, right? DynamoDB streams can do this. And then you start thinking about, oh, does that cost me money or does it actually save me money, right? Because maybe now I don't need to route things through EventBridge anymore and I use EventBridge pipes, right? New thing we released last year at reInvent. And then that has, a 10 cent per million message versus 40 cents per million message. And your lambda gets smaller also, right? Those are small amounts, but they add up, right? If you don't need to send the message from your code, that reduces the footprint because the library doesn't need to be linked in. It reduces your runtime so that your lambda becomes more responsive. And if you have something synchronous on the front, right, actually just updating a database makes your front end snappier and lower latency, and you do the rest asynchronously with DynamoDB streams. So there's really nice, so not all of them are one-liners, right? But there's some really nice nuances that you can play with. And you guys, we will share the links here. You can have a look at where, so I'm really dissecting one example in a lot of detail.
Yeah, and we started for each of those motivators that you saw, leveraging platform capability, or as AWS is evolving, we have started building a catalog of the patterns that you can see. For example, Gregor talked about DynamoDB stream. So if you have a Lambda function, which is sending a message, which is updating your database or persisting your domain, and then sending a message maybe to an SNS. So instead of the Lambda doing both, you can have Lambda persist the data, and then you can use EventBridge pipes, which is a feature that came out very recently, which is used for point-to-point integration, then have DynamoDB stream push that to your SNS. So that's another way where you can reduce code, take advantage of the platform capability. And similarly, in our next category, where the AWS platform is evolving, here is an example where, say, if you have a step function which is making calls to AWS services but then using Lambda, for example, step function calling recognition but then through a Lambda, then that's another example for refactoring. We have SDK integrations that are directly allowing you to call services from step functions. So you can take away that Lambda and directly make a call to recognition API. And every time you are using Lambda just for connecting to services, that is an indicator where you can look for refactoring, because we say use Lambda for transformation and not to transport between two services.
Yeah, somebody just commented also in the comments just that, right? Spot on. And the last refactoring in this category, that was actually myself, right? So I'm just like, oh, I need to read something from DynamoDB. Oh, I should probably write a Lambda that does that. And then I realized, oh, I don't really need to, right? It just costs me money. More moving parts provides more value. I can read the DynamoDB from step functions right there. So take that out. So some of these refactorings come from our own experience.
Yeah.
And back to the original point of refactoring the refactoring, this is part of the discovery of what's possible with a platform and what you can do. Yeah, because I looked at that, it was great. You've got a Lambda function which has 2 bits of functionality. One is to send something to DynamoDB, and then one to send something to EventBridge. So you take the EventBridge part out of it and just listen to the DynamoDB change stream, and EventBridge pipes goes and does something. But if you only do something with an SDK integration, the Lambda function doesn't even need to exist. You could have a step functions workflow that writes it directly to DynamoDB and pipes it and picks that up.
Yeah, and we have
like,
over 250
oh my God.
SDK integration. So yeah, definitely look for those areas.
Yeah, and Julian's example is great, right? Because if the source of this is not a Lambda function, but a step function, making 2 steps would make very little sense, right? So now you can have step functions to DynamoDB, and then DynamoDB streams publish the event from that. So that makes a very nice event-driven chain versus sort of doing multiple things. You have to deal with errors. What if the database update succeeded, but for whatever reason, my event didn't publish because I monkeyed something up, right? So all those kind of things go away. And that's why we like those refactorings. They do improve the structure of your solution.
Yeah. And we have these catalogs on, but I want to jump to the trade-offs, because in the beginning we did talk about, like, being aware about trade-offs. Would this be a perfect, like Martin Fowler mentioned, it shouldn't change your behavior, but would there be any side effects? So let's take this example where, we talked about the Lambda sending to the message queue, and we refactored that using Lambda destinations. So did this refactoring actually preserve the behavior? So when you look into that, the first thing is Lambda functions can be invoked either synchronously or asynchronously, but the Lambda destinations will trigger only if your use case in which the Lambda is asynchronously invoked. So you have to be aware about the invocation pattern and then apply refactoring. You can't just look at a code and then, oh, I see this, maybe I should change it. See how the invocation is, and maybe then see if it's a right fit for your use case. And also, if you look at the message that was sent when using your code versus message that was sent using destinations, that is a slight change. So that is what you're seeing on the screen in that white boxes. On your left is the message that was sent using code. It's a simple JSON with an action, say, bake a pizza. And on the right is the SQS message that was sent using the Lambda destination. So you will see that the message is wrapped with all the metadata about the event. So what this means is that for your consumers of that message, there has to be some code change. So they will have to now parse out that message. Message is still there, but they'll have to change maybe their regex to parse out that message. So I would say this is a small side effect of using a Lambda destination for SQS. And again, this is where you think about, like, what are the trade-offs? This is, I would say, like 95% behavior preserving, but then at the end you get a platform which is better. You reduce your application code, you separated the concern between your business logic and topology.
Yeah.
And funnily, if your destination goes from Lambda to Lambda, you can disable this. You can choose whether the envelope goes on or not. But if it goes to SQS, you cannot. Like, don't ask me why, right? So maybe one day, this is something we can change. So there is an option for Lambda to Lambda destinations, but not for Lambda to SQS. And then this would go away.
Yeah, and I suppose this is interesting because part of the destinations feature was only sending metadata about the event, so you could take subsequent action on that. But yeah, actually having the response payload is important. And I just want to bring up Brian's comment. Thanks, Brian, for joining us. And yeah, just to say, we can actually go a little bit long today. We don't have to literally finish in 40 seconds, which would be insane. Because we were going a little bit earlier, I think we're okay. Yeah, but Brian said, should Apple Infracode handle the payload mapping that SQS expects? And that was the original thought, I think, is, you're taking it out the application code where you may be doing some formatting or putting this all together. And I think we've sort of answered that specifically with SQS, that the response payload is in the SQS envelope that's sent via destinations as well. But yeah, maybe different with other destinations.
Yeah, my question there would be, is it the mapping that SQS expects or that the receiving
application
expects, right? So there's a sort of the actual payload, which that's your application logic and your domain object. So they would be clearly in the application, code. So I'm not sure whether Brian is referring here to like the header fields, right, or other things that are related to SQS, right? In case of the destinations, that is generally defaulted. Like the Lambda doesn't even know that it's publishing to SQS. That is all done by the automation code.
And I think there's a benefit to that because there's less brittleness in your code because your code is not going to mess up the headers or whatever the formatting of your response to SQS because the platform's just handling that. It's just going to, whatever response your Lambda function is sending, gets sent to SQS. You won't mess something up with Botto3 in your example by sending to SQS, for example. And also, if there are any retries or issues connecting to SQS, the Lambda platform is going to handle those retries on your behalf. So you don't have to, again, put that into your function code.
There was a question from Alper. Can we even conclude that refactoring preserves behavior without tests? That's a really good question, and that sort of leads us into sort of fast forwarding this movie, right? We said originally with sort of the traditional code refactoring, the tool does it, right? I'm a big fan of IntelliJ IDEA, right? I just got to right click. Well, I don't even right click. It's also Control Alt V, introduce variable, extract method, right? These kind of things. You don't even think about it. So the question is, can we get, or how close to that can we get with serverless refactorings? So I would say we can get further than we are now, but we need to remember that we're dealing with distributed systems which have more nuanced runtime characteristics than one method versus two method, right? Like a call stack, a method call, your JIT or your compiler will take that probably out anyway. So the runtime characteristics for extracting method in the code example really minuscule, right? So I think here we need to acknowledge that the runtime characteristics could be different. And in some cases, actually, that's what we're after. So I don't think we want to make it sort of auto magic, right? We want people to understand that there's sort of cost latency and other implications, sometimes positive, sometimes to be taken care of. But where I think we can get better is have tooling support for this, right? So for example, like Sindhu mentioned some example, right? I can use EventBridge for many filterings, but the day might come where my filterings get so complex that I need to make a Lambda function. If I was dreaming, so not speaking as sort of the serverless engineer here, just like making up random stuff, could there be a right click on EventBridge in the console, say, make that into a Lambda function and it code generates me that? And the short answer is, yeah, you could probably build that. Right? It's like all open source, right? You can call the API, see what rules you have, what filtering you do, and you can actually convert that into a Lambda function. Funnily, EventBridge actually uses Ruler. That's an open source library. So you could actually include that library in your Lambda function and get a fully equivalent Lambda function. So I think there's some really nifty things you could do here, but I wouldn't want to pretend that it has no impact on the runtime characteristics, right? You need to always keep in mind you're building distributed systems here, and that is not something that you can sort of wipe off the table. That would be, I call this, we want to make nice tools and abstractions. We do not want to make illusions, right? And if you sort of pretend that the runtime stuff isn't there, to me, that sounds like an illusion, and that's good for magic tricks. It's not good for software development.
Yeah, and the last one in this slide before we move on is the way the Lambda destinations are invoked. So Lambda destinations get triggered at the end of your function execution. And in most cases, it doesn't matter when you send the message to your downstream. However, if you have like a very specific use case where it has to send that message at a specific stage of the business execution, maybe this is not a good place for you to refactor using destinations. So yeah, keep in mind what your code is doing and to then validate if it's a right fit for that particular refactoring or not.
Yeah, the architect would probably say if the order matters, you probably have some really weird side effects because sending the message is asynchronous, right? So you should probably go refactor something else. But of course, we don't want to sort of easily brush this aside. Yes, the destination sent at the end of the execution. So if you have something expensive, for example, that you're doing after, right, the message, you might have latency, right? That might be one plausible scenario where you said, that is something I don't want. So I do want to send a message earlier, or you split it into two lambdas, one that does the heavy stuff and one that does the lightweight stuff, and send the message, right? And these are exactly the kind of discussions we want you to have. right? If your Lambda has a light and latency sensitive part and a heavy part, maybe two Lambdas are better for this, scales better in the end, it might be more cost effective, right? And that's what all these refactorings are about.
Yeah. Do we have time for another example or?
Let's go for it.
Okay. So let's see maybe another example. Here, in this example, we are going to be using Amazon recognition. So if you're not aware or never used Amazon recognition, it's a fully managed image and video analysis service. So using this, you can detect objects in your image. And I'm using Amazon recognition API to detect if the image in my S3 bucket is a pizza. Maybe I was hungry at the time of writing this code, so all my examples are around food. So
I know somebody who does that. They actually take pictures of the pizza for quality assurance and then use machine learning to make sure that the pizza workers put the right things on the pizza. So this is a real use case.
Yeah, this could be a part of a workflow where at the end there's a quality control, which is make sure that the order was a pizza. So in
counting
this example,
pepperoni. How much pepperoni in my pizza? Don't shortchange me on my pepperoni.
They do. Yeah.
So yeah,
But
on your left, so is the code, and it is and it is using a step function. So it's part of our orchestration. The step function calls a lambda. This is where I was talking about again. If you're using lambda for transporting, so it's calling a lambda function, which then calls your recognition API. And this is a very common pattern that, as I said, we see where lambda is used to invoke another service. So how do you refactor this code? Is you'd start taking advantage of step function SDK. Now, this is where you can directly integrate with over 250 AWS services, and then you can make a call directly from your step functions to your Amazon recognition API, getting rid of that Lambda function altogether. And you can combine this with step functions, intrinsic functions. So if you want to do some basic transformations, you can get away with Lambda using that. So a general recommendation, look for places, use Lambda for transforming data and not to transport. And because we got rid of that Lambda, you don't have to worry about like maintaining code. So talking about code, on your right is the code for what it looked like before. So on the top is your CDK, and on the bottom is that Lambda. And as you see, this Lambda, all it does is invoke the recognition API. And when I refactor that to use the SDK integration, that's what you see on the top, the grade bottom, which says call AWS service. So this is where I'm directly calling my recognition API, and then there is no Lambda code now. And so you don't have to worry about maintaining your code or like Node.js, no 12 going out of support. You don't have to worry about updating libraries. And you are also saving costs because you eliminated one extra hop in your workflow.
yeah, and I have a real example for this. Like, so in this case, it's 0 lines of code, application code, which is perfect because yes, you don't have to deal with runtime patching or things going out of support. And I have a real example where application code was actually sending an event and it had a bug in the date. So it swapped month and day in the event that it was setting, and everything was working great until February 3rd. On February 2nd, everything was working fine, and then the damn thing stopped working. Excuse my French here, because instead of February 3rd, it was March 2nd. And then CloudWatch says, oh, that's far in the future. I'm not going to log this event. And it cost me like endless hours of late night. DynamoDB streams is not going to make that mistake, right? So if you use the platform, right, the platform will not do silly little mistakes like you could have in the code, which in the end can really drive you nuts. So having this example have 0 lines of application code is actually my preferred. I wouldn't stick the no code label on here. I'd be careful with that. But actually in this case, right, reducing application code in favor of automation code really saves you a lot of headache.
Yeah, and also talking about like being careful is like if you are using Lambda for a lot of complex transformations, then maybe that's a good use case and you want to keep that in. But in our case, it was just calling out the API.
Yeah, and of course, I have some fans here, or at least one fan, my one fan in the comments. Yes, the Gregor grams,
I think
right?
that is
Like,
fantastic.
yeah, if
Gregograms.
you actually sort of amplify the topology, like, how does stuff flow and how does stuff connect? Yes, I think the enterprise integration patterns, 20th anniversary coming up for that. So some stuff does pass the test of time. I think those are really nice and expressive ways to describe the topology of a message-oriented application. And if you're watching very closely, you see them showing up already in two instances, like Event Bridge Pipes has an enricher, right? And the enricher, that's clearly one of the integration patterns. And also we have on the AWS compute blog, we have a blog about mapping other patterns to pipes. So we are finding that using the integration patterns vocabulary is actually really helpful here. And if you sort of string two and two together, you can imagine they could build some pretty nifty tooling around this as well, right? And then these refactorings become much more visual, and you can really see the topology of the application, for example, in a visualization.
There is a question from Alpa Codes, and I know he's gone on to say that Sindhu has answered it super well. Can we overdo refactoring when we end up in a situation where business logic is sprinkled all around infra in message filtering, step functions, transformations? And just to go back to the second part from Sindhu answered, you may want to refactor complex transformations to a Lambda function. But just to go back to the original, is there any overdoing you can do in the refactoring when it does get too many things strung along in a sequence for an async sequence? Are there any thoughts of it? There's too far you can go on this, or that's just a natural evolution of doing this in a well architected serverless way?
Yeah, a very good question, right? And the refactorings are a catalog, right? It's a list of things that you can do. There isn't sort of a prescribed sequence, or these are the refactorings that you need to do. Now, you can overdo most good things, like think about our classic code example, extract method, right, where sort of refactoring comes from. You could imagine somebody sort of making a million methods which each have one line of code, right, because they extracted everything in another method, and then you sort of like, yeah, that wasn't really great. So I think same applies here. You want to apply the refactoring to improve the structure of your code. Now, improve is a little bit human judgment, and I think that's properly so, right? Some people prefer smaller methods, to just stay with that example, and often that goes along with better tooling, right? In IntelliJ, I like small methods because I can go to definition very quickly and maneuver this, right? In other environments, I might not have that. So I think the human should be the judge of sort of what's improving, your immutability, maintainability, and the runtime characteristics. And the catalog is at your disposal, but there isn't sort of like, oh, you need to use 9 out of 10 refactorings. It reminds me sort of a little bit in the early days of design patterns. People try to say like, oh, the quality of your solution is sort of measured by how many patterns you use, and people quickly abandon that. So yeah, this is just your toolbox, and you use your judgment to make sure that this actually improves your solution and doesn't sort of make it worse, right? You don't want to have 50,000 Lambda functions with one line of code, right? That is not the goal here.
Thank you. And yeah, just one other question, which thanks for joining us via Twitch. Will there be any auto suggestions when there is an opportunity exists to do such refactoring? The first thing that popped into my mind is things like some of the new ML services. That would be amazing when you do a comment going, write something to SQS. Imagine if it didn't suggest a code example, but said, well, actually, you could use this with a Lambda destination or in a different way.
I like this a lot, and in some way you could even do this as open source, right? Because with the APIs you can read the topology. Now it is easier when most things are already in the infrastructure with air quotes, right? If it's in the automation layer, because the automation layer and the resources that you create, they're more easily readable and parsable to make these kind of recommendations. But I think so that AI-assisted coding, like Code Whisperer and Copilot and those kind of things, right? They're clearly going in the direction so that when you're sending that, when you're writing the code that Sindhu showed, right? If you're like, hey, please send my SQS message in Lambda, that you could imagine it saying, hey, did you consider using a destination for that? And then in my dream, right, it would even sort of try to at least suggest you a snippet of code like CDK code, where you can say like, paste that into your CDK code so you get the equivalent automation there. So that would be really, really cool. And if anybody has sort of interest or ideas in building something like that, I think that would be super exciting.
Yeah, recommendations for your code. That would be awesome.
Yeah.
So then just to ask, I mean, if other people do have an idea for refactoring, is there some place they can submit them so we can get this good library happening?
So the home for this is on serverless land, and I think we have the links in here. That's where the catalog is. We're still adding to that. I don't know, Sindhu, whether we have sort of an official email alias. I just know like I'm pretty easily reachable online on Twitter and LinkedIn and stuff.
Yeah,
so
I think we have our email addresses. Reach out to us. And I think we can also show the page. We have a QR code where if you want to learn more about, we covered 2 of the patterns here, but we are constantly adding more patterns to the site. So you can find our patterns there. And also it will have a link of how you can contribute, because we're also adding code examples. So you can, take that as your starting point. So reach out to us using, I think, right, we haven't thought that far in terms of making like a group email, but yeah, reach out to us. If you have another pattern that we haven't covered, if you have a suggestion that, might improve for others, this is a community project. So definitely we're looking to hear from you.
Yeah, and CDK is open source, right? A lot of this is open source. As I said, some of the ideas I heard here on the questions are superb, and some of these things might actually make great community projects, right? It doesn't necessarily have to be an AWS service. You see this with the CDK patterns and many other things, where really it being open source has spurred like a whole community around this. And I'd be super happy if something like that happens to the refactorings. I definitely don't want to be the person who claims to have found all the refactorings. That would be a failing, right? This should come out of real experience where folks can contribute.
Excellent. Well, thank you very much, everybody. We've run over, so yeah, we do need to head off. The next show is going to start, but really appreciate your time, Gregor and Sindhu. Yeah, phenomenal talk today, and yeah, thanks so much for joining us.
Yeah, thanks for all the questions.
Bye.
Excellent. Just to let you know, next week I'm going to be away. Eric Johnson, the one and only, is going to be talking about more visual things, EDA visually explained. So yeah, that'll be really good. So yeah, join us next same time, not same place, same place, not same time. Oh dear, I'm going mad. Next week for Serverless Office Hours. Also serverlessland.com. We've got patterns, workflows, snippets, repos, all these kind of things, so you don't have to reinvent the wheel yourselves. And maybe we'll have a sort of refactoring section for that coming soon. But yeah, thanks so much for joining us, and thank you again for Gregor and Sindhu. Amazing session today. Lots to think about. Thank you again.
Yeah.